Alright, I'm going to start this one off by making up my own problem, and then you can kind of just do the same thing with the problem you have. So, mine's going to be, I'm just going to use the continents South America and Africa. How about that? And let's pretend they're, well, yours is like 3,000 miles apart? Yeah, fine, mine's going to be 5,000 miles apart. And then say continents move at a rate, and I'm not going to use millimeters, that way you can just apply the same principle and do it on your own, because I'm not going to give you the answer, but say they move at like 0.5 inches per year. Alright, so you've got two continents, Africa and South America. They're 5,000 miles apart, and continents drift at 0.5 inches per year. And so, essentially what you have is you have a distance of 5,000 miles, and you have a speed of v of 0.5 inches per year. So you write down your knowns, right? D and V. And inches per year is the speed because that's a distance over time. And the question asks for time. How long? Yeah, it's asking for time. So your T is your unknown. You got that? Now you know that if velocity just equals equals distance over time, correct? Then you can do algebra and you can rearrange that equation to be T equals distance over velocity, correct? So, and then those two things, you have those two things. You have a distance of 5,000 miles and a speed of 0.5 inches per year. But the thing that's wrong with this is that your units are not the same for your distance and they're not the same for speed. Because years you can leave by itself, that's okay, but you have a units of distance in inches and a units of distance in miles. So there's two ways you can go about this. You can either turn the miles into inches or you can turn the inches into miles. And I've done it both ways on this other piece of paper, but I'll just show you the miles for now. So you have a distance of 5,000 miles, alright, times, so 1 mile, alright, and anytime, like, whatever unit you want in the end has to go on top if you have like a ratio or a fraction. So I mean, like, say we were converting inches per year and the final units you needed are inches, so inches are going to be on top. If you wanted year in the end, you'd have to flip them, so it'd have to be 1 over 0.5, because it'd be 1 year per 0.5 inches, because you want years in the end. But that'll come back later. For right now, Winston, shut up! Alright, so you have a distance of 5,000 miles, and you want the miles to cancel out to give you some other units. We're going toward inches for this specific problem. So 1 mile, now you could just skip all the way over to inches, but it's generally easier to go step by step. And this is just like common knowledge. It's that 1 mile is 5,280 feet. So 5,280 feet, right? You see that? So the miles will cancel out. And if you just do that algebra problem, you'll get the distance in feet. But we don't want feet, we want inches. So we need to find out how many inches there are in 1 foot. And that's also common knowledge. And all this stuff you can probably just look up online as well if you're stuck. But we know that 1 foot is 12 inches. So 12 inches. Cool. You see that? So cross those out. And now all we have is some numbers, multiply them together, and inches are left in units. So that comes out to be it ends up being 316,800,000, but I'm going to put that in scientific notation to make it easier to look at. But in the end, we get 3.17 times 10 to the 8th inches. Alright, so now we can pretty much solve the problem because, one, you have a distance in inches and you have a speed in inches per year. So now you can find out how many years it takes for those continents to drift apart. So we go back to the equation T equals D over V, as we got before, right there, which we got just from simply messing around with the velocity equation, right? And you just kind of plug D into the top and V into the bottom, and you'll get 3.17 times 10 to the 8th inches all over velocity, which is 0.5 inches per year. Alright, so see that? And what you have is, because velocity in itself is already a fraction, you want to keep that on bottom. But you know that if you divide something by a fraction, say for instance, this is just a quick example, A divided by B C's, or B over C. That's one fraction, and that's these little bracket line things you see on the side. That just makes it easier to look at whenever you have like another fraction divided by another fraction, so you know what the big like which fractions are being divided by what, so you don't get your lines mixed up. So that's just useful notation for the future. But you know that A divided by B over C is the same thing as saying A times C over B. Essentially what you do is you keep A by itself and you just flip the B over C and make it a C over B. That works for others. Say you had A divided by B over C over D. It's the same thing as A over B times D over C. You may already know this, but I remember you had a question earlier, and this was the way to have solved it, but you didn't get it. But yeah, A over B divided by C over D is the same thing saying A over B times D over C. You just flip the bottom one and multiply. So back to this problem, you've got 3.17 times 10 to the 8th inches divided by 0.5 inches per year. That's the same thing as flipping it. And remember, 0.5 is on top, so your fraction is going to look kind of weird, but it's okay, it works out in the end. But it's going to be 3.17 times 10 to the 8th inches multiplied by 1 year over 0.5 inches. Alright, you see this? Because you've got 0.5 inches per year. When you flip it, you'll get 1 year per 0.5 inches. Because those 0.5 and that inches are tied. Now, you could make it easier to look at and just change this to a 2, because 1 divided by 1/2 is the same thing as 2, but if you're just going to plug it in your calculator, you can leave it like this. And then, so yeah, just plug that in your calculator. It'll be 3.17 times 10 to the 8th divided by 0.5, and you'll get 6.34 times 10 to the 8 years. Because what happens is your inches cancel out and you're just left with years. So you know that it took those continents 6.34, that's 634 million years to drift apart. This is not going to be the same answer as the one on your test. Like, yeah, you saw I just made up different numbers, but it's the same thing. What you want to do with yours is you're given miles and you're given millimeters per year. So you're going to want to find out how many millimeters there are in a whole mile. That you can look up the conversions, online. And you can do it either way. I didn't show you the other way, but that's taking millimeters per year and changing millimeters into miles. but it's probably easier just to go from miles to millimeters. So if you have any other questions, just go ahead and tell me. I'll get back to you as soon as I can.